Hello everyone, today we'll do non-linear optimization, and this time we are minimizing cost and risk of energy production from different sources. Now here in this case the risk would be quadratic function, and we want to combine cost and risk, cost plus risk, and we want to minimize the objective function for these two, for the sum of these two. So we are importing numpy as np, and from sciencepy dot optimize import minimize. Good. And after that I'm going to define the objective function. This time we are calling it objective function because it is not going to minimize the cost only, it will minimize cost and risk as well. So the cost is 20 times x0. Again, we have three types of sources of energy production. Suppose wind, solar, and oil. So I think everybody understand what it means. $20 is the cost per unit from wind, 15 from solar, and 40 from oil, right? Now I'm going to define the risk. Risk involved, for example, we are saying the same 10% from each of them, and it is squared function. You can say quadratic function for all three sources, right? And then you can return the sum of cost plus risk, and we want to minimize cost plus risk. That's why it's called non-linear optimization. Okay, so the next is constraints. Constraints equal to, we define constraint like this. First of all, the type, and we write equation, and then function would be, now we have to define that, lambda x and numpy array of instead of writing, this is also correct, but I'm going to write sum of x, sum of x minus 100. There's no need to put the brackets here. What it means, sum of x minus 100, actually we want to say that the constraint is like this. You can say x0, x1, x2 is 100, right? number of units from sum of number of units from each type, wind, solar, oil, must be equal to 100. That's the constraint, right? So constraint is done. After the constraint, we will write the bounds. Bounds are from wind 0 to maybe 60. Bound for the solar is 0 to 80, and bound for the oil is 0 to 100. Everything good. So we define the objective function, constraint, and bounds. One more thing left. Initial value, x0. So for example, you can say 30, 30, and 40 for each. And now we are ready to apply minimize function, objective, initialize, and then bounds equal to bounds, constraints equal to constraints, because we are using the same names for bounds and constraints. Okay, minimize, objective, bounds, constraints. Let me check. Constraint is correct, bounds is correct, x0 is correct, objective, the name of the objective function is objective. Everything looks good. Where is the problem? x2 is not defined. That's what they're saying. x2 is not defined. So we have to go back to x2. Okay, yes. Here they're saying why you are using x2 symbol here. That was the problem. So instead of writing x2 bracket 2, I should have written x bracket 2 for the third variable. And now it is working. Great. Okay, now we can print the optimal solution. That would be a result. Okay, they're saying this is the solution. The first type must be 37, second 62, third almost 0. Okay. They're saying use 37 units from wind, 62 approximately from solar, and almost 0 from oil to optimize the objective function. So let's see optimal objective value. So objective value would be for cost plus risk 2218, suppose dollar, right? Okay, so that was optimal solution of non-linear optimization technique. And I think that's enough for today. Thank you. Be happy and see you next time.